Hello and welcome to 9.6 Notes. Today's topic is on symmetry, and the goals for today is to identify line and rotational symmetry of a figure. Okay, to be able to identify line symmetry and rotational symmetry. So let's start off with line symmetry. Okay, a figure in a plane has line symmetry if the figure can be mapped onto itself by a reflection in a line. This line of reflection is called a line of symmetry. And a figure can have more than one line of symmetry. And I think the best way to get this concept across to you, especially through this YouTube presentation, is to just go through some examples, and I think you'll get it by the end of the examples. Okay, let's start off with this example. How many lines of symmetry does the object have? And the first object we'll look into is this one here in letter A. So we have, the answer is 2. There's 2 lines of symmetry. And so what that means is, for example, that would be the first one. And what you could do with this line of symmetry, pretend it's like if you took this figure and you put a crease in the paper, and then you folded it over the line of symmetry, or folded it over that crease, this side would fit exactly onto that side. So that's called symmetry, or like sameness for both sides of the figure as across or about the line of symmetry, right? That's you can also consider it like this is a plane mirror or a flat mirror, and if you had an object that looked like this and you put it against a flat mirror, the image would be this. Okay, so that's symmetry. But there's 2 lines of symmetry. The other line of symmetry is that. So again, you can also take this line of symmetry, this line of reflection, and you can pretend it's a crease in a paper and fold it across here, and this part of the figure would align exactly with that part of the figure. Okay? So that's an example of line of symmetry of this figure. So moving on to the next figure, how many lines of symmetry does this have? Well, you can pause this presentation anytime you'd like. Remember, you're in total control of the presentation, and you can give it a shot yourself and give it a try, and then continue with the presentation, and I'll give you the answer. But for the sake of this presentation, I'll just continue. Okay? So the answer is that there are 6 lines of symmetry in this figure. Okay, there's the first one. Again, you could fold it across that crease or that line of reflection, and the 2 sides are congruent. They would map onto each other. And there's another one. That's 2, 3, 4, 5, 6 lines of symmetry. Okay? Next example is this right here. How many lines of symmetry this have? Again, you can pause it if you'd like and give it a shot, but I'll continue at this point. This has only 1 line of symmetry, which is right there. And this would be the line of reflection, and those would be the 2 sides of the figure that could map onto each other. That's the only one. You couldn't have, for example, that, because obviously if you take this side and try to map it over to that side, it wouldn't be the same. It's not the same. There is no other line of symmetry other than that one. Okay? And then moving right along, what about the picture of this flower here? How many lines of symmetry does it have? Again, you can pause this presentation if you'd like, give it a shot, but I will continue. It has 8 lines of symmetry. Here's 1. Both sides of that figure are symmetrical. 2, both sides of this figure, this half and this half, are symmetrical across this line of reflection. And here we go, 3, 4, 5, 6, 7, and 8. Okay? Alright, and then the last one is how many lines of symmetry does this starfish have? Okay? And that's 5. There's 1, 2, 3, 4, 5 lines of symmetry. Okay? And actually we have one more example here. The face of this sheep, I guess it is. Sorry, I didn't grow up on a farm. I don't quite know what that's supposed to be, but I guess it's a sheep. How many lines of symmetry does it have? Well, just one. Okay, and for this figure, I think that's true. But for those of you who are biology majors or going into biology in the future, if you want to be technical, the left side of your face doesn't equal the right side of your face. It's not totally symmetrical, right? But for the most part, yes, that at least mathematically that maps onto itself. Okay, so it only has one line of symmetry. So that's line symmetry. The next concept there is rotational symmetry. So a figure in a plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. A couple of important things there. It has to be 180 degrees or less, okay, and it has to be around the center of the figure, okay, and that point is called the center of symmetry, and a rotation can be either clockwise or counterclockwise. Okay, so again, I think the best way to explain this is through examples. So we have this other example here. Does the figure have rotational symmetry? That's the first question. And then if so, describe any rotations that map the figure onto itself. So the first figure is this rhombus here. Can I take this rhombus and rotate it 180 degrees or less and have it look like this figure again? That's the question. And the answer is yes, it does have rotational symmetry. So we have to describe any rotations that might map the figure onto itself. What that means is just say what the degrees are. And the answer is it's 180 degrees about the center. So if this here is the center, approximately around right there, kind of giving it my best estimate, and then 180 degrees means if I take this figure, put it here, this part of the diamond, this part of the diamond goes here, and it would look the same. Okay? If I just went 90 degrees, for example, and just put that up to there, it would not look the same. It would be maybe something sort of like this. Well, that's not a very good drawing, but that would be kind of more. So it's something like that, which is not symmetrical. So it does not have rotational symmetry at 90 degrees. It only has rotational symmetry at 180 degrees. Okay? And then the next figure is this beautiful octagon. Does it have rotational symmetry? The answer is yes. And so let's describe it. And that would be at 90 degrees or 180 degrees. So if I took this figure and went all the way around here, and then this one all the way around here, and of course this would go all the way to here, and that would go all the way to there, it would basically look like this figure yet again. And if I went 90 degrees, in other words, that just went to here, and this just went to here, and this just went to here, and this just went to here, it would look like this again. And those are the only 2-degree measures for which rotating it about the center would make it have rotational symmetry. Okay, and then one more example is this right triangle. Does it have rotational symmetry? Well, the answer is simply no. So there's nothing to describe. There are no degree measures to describe, right? I couldn't take this figure, rotate it any amount of degrees, 180 degrees or less, and have it look like that. Impossible. So it does not have, a right triangle does not have rotational symmetry. Okay. One last example, you'll get problems like this as well, where you'll have to put the two concepts of line symmetry and rotational symmetry together for any one figure. So let's tackle a problem like that. Describe the lines of symmetry and rotational symmetry of a non-equilateral isosceles triangle. So what they're referring to is that. That's a non-equilateral isosceles triangle. So it's isosceles because that equals that, but it doesn't equal this side. So it's not equilateral. It's not three sides the same. It's two sides the same, and then the base is different. Okay. So does this have? First off, let's talk about line symmetry. Does this have line symmetry? Again, you can pause this if you'd like, but I will continue at this point. And yes, if you go like around there, and if you were to fold the figure about that line of reflection, that figure would map onto itself. So it does have line symmetry. And what do we call that? Okay, this drop down here. Well, it's drop down from the vertex perpendicular to the other side. Can you remember what that's from? I believe that was chapter 5. That would be the altitude. So the altitude is the line of symmetry. Now let's answer this question. Does it have rotational symmetry? And there is no rotational symmetry. I cannot take this figure and rotate it about the center of the figure and rotate it, 180 degrees or less and make the figure look like this again. The only way to make this figure look like this again is if I went around all the way around 360 degrees. If you can take a figure and map it onto itself by going only 360 degrees, that's not rotational symmetry. Taking any figure and making it go around 360 degrees is just making it go in the same position again, and that is defined as not having rotational symmetry. Okay, so that's the end of the lecture. If you have any questions or concerns, as usual, please feel perfectly free to contact me at your convenience, and it would be my pleasure to help you. Okay, bye-bye.